Hey guys, how's it going? This is Carl, and we're jumping into week 9, problem number 5, and just go ahead and touch and base. A market analyst wants to know if a new website he designed is showing an increased page per views per visit. Customers randomly selected sent to one of two different websites offering the same products but different designs. Some of the data comes from distribution that is normally distributed. So website 1, you kind of see it right here. Website 2, and you see our calculations that we've already begun in terms of the average, which is the mean, and the variance as you calculate. And notice just with Excel, it's 2007 var.s because we're dealing with a sample. We're not dealing with a population. Excel 2010 can give you a population variance and a sample variance, but in this case, as it's stated in the problem, this is a sample. Test the null hypothesis in alpha using the pooled t-test. So remember, a pooled t-test is a hypothesis test for the difference in the means of two independent groups. We're willing and able to assume that the variances of the groups are equal, and the hypothesized difference of this problem is 0, or delta. So going down a little bit, what we're going to do, the t-statistic will help us calculate a p-value. And our t-statistic's calculated just down here. You see y1, the mean, minus the difference, which is what we discussed about earlier. The hypothesized difference in this problem is 0. That's delta in this case, divided by the standard error pooled, y minus 1. So before, we need to calculate this right here. We need to calculate our S pooled, which will help us out a lot. So because S pool is related to standard error pooled, so you can see right here, standard error pool equals S, the variance pooled times a certain number. Square root of 1 over n1 plus 1 over n2. n2 being the sample sizes. So as you can see here, there's 5 sample sizes. The mean difference between the two is 4.4. How did we get this number right here? Well, this is the mean difference, so you're taking the differences between the two averages. And here we go, we're calculating our S pool right here. As you can see up here, it's quite a bit of numbers actually, when you think about it. 5 minus 1 times 5.2. We're using the variance, remember? Essentially, this is y1, it's y2 divided or multiplied by the S1. So you really have to kind of take some practice to kind of nail down these concepts. Or n1 minus n s1 squared. You can see it right there. S1 squared is the variance plus n2 minus 1. You can see it right here. Divided by n1 minus 1. You see it right here. n2 minus 2. It's the same problem throughout, in terms of sample size and stuff like that. And as you can see, this is the calculation that we arrive at. And then here we squared 2.23 as a result. Now remember this, SC pool equals the standard error pooled equals this variance pooled times this certain piece of it, square root of 1 minus n1 plus 1 minus n2. So we fold that into there. This equation right here, you can see it right here, C23, which is our S pooled because this is our calculation, times the square root. You can see times the square root of 1 plus 1 over 5 plus 1 over 5. You can see that's how we figured it out. And that gets us our standard error pool. Well, now we have our standard error pool, and we have the true difference, as you can see right here. We have our mean difference, which is 4.4. So our test statistic, we have this is 4.4. Delta is 0. Remember in the hypothesis, delta is 0. And then the standard error pool, we just calculated it not too long ago. It's right here. But before that, just as I've noted, we had to calculate the S pool to complete this equation. So you put all of those in there, it's essentially 4.4, the true mean, or the mean difference rather, minus 0, the hypothesized difference, divided by G25, which is our standard error pooled. And you get 3.11. Now, that doesn't stop here because we want to test it. So we need to find the p-value for this value. Now remember, this is a test statistic. This is a t-value, or it's going to be crucial to use our t-distribution because this is a t-value rather. So what we want to do is using the t-distribution function or t-dist function. A29 is up here. What we're looking at is the fact that, okay, this is our value that we're using, and then the degrees of freedom is 8. And then the number of tails is 1 as specified. And that's what we're able to get, 0.007. So if it's, as we scroll down, reject the null if the p-value is less than or equal to the alpha. And you can see alpha being what? 0.05 in terms of the confidence level. So therefore we reject the null because that is less than or equal to alpha, which is 0.05. When you say 95% confidence interval, or 95% confidence, when you say that in terms of research, in terms of studies, it's alpha is 0.05 in that. So just a FYI and kind of a refresher. But we just hope this helps, and just let us know if you have any other questions along the way. Thanks so much.